Alright, welcome back. In the last video we were looking at different matrices and we were trying to figure out if they were in row echelon form, reduced row echelon form, or neither. And just to recap, if a matrix satisfies these first three rules, we say that that matrix is in row echelon form. And if it also satisfies this fourth rule, then we say that that matrix is in reduced row echelon form. So in this video I want to continue on with a few more examples just so we really understand what reduced row echelon form and row echelon form are. So this matrix down here is a 3x4 matrix, 3 rows, 4 columns, and we want to try to find out if this is in row echelon form, reduced row echelon form, or neither. Well, the first rule says that all zero coefficient rows are at the bottom of the matrix. Well, if we inspect this matrix, we notice that row 2 has all 0 elements. And since this is not, or this row is not at the very bottom of the matrix, then it does not satisfy rule 1, and therefore this is not in row echelon form, and it also cannot be in reduced row echelon form, right? So let's go ahead and look at another example. Let's say we have this matrix right here. This is a 4x4 matrix. Well, we can see that all 0 coefficient rows are at the bottom of the matrix. So this row down here has a row, or has all elements that are 0, and it is at the very bottom of this matrix. So it satisfies rule number 1. How about rule number 2? All the other rows, so these 3 rows right here that don't have rows consisting entirely of 0, the first non-zero entry from the left has to be positive 1. So if you look at row 1, the first non-zero entry here is a positive 1, so row 1 is good. How about row 2? Well, the first element in this row is 0, and the second element, which is the first non-zero element that we encounter, is a positive 1, so that row is good. How about the third row? Well, we have a 0, 0, and the first non-zero element that we encounter going from left to right is a positive 1, so that row is good. So this matrix satisfies rule number 2. How about rule number 3? Leading ones of each row are at least one space to the right of the leading one above it. So for the first row, we have a 1 in the first column. And rule number 3 basically says that the leading one term in the row below it has to be at least one column or one space over to the right. And we can see that in row 2 that this is true. How about row 3? Well, the leading one term is here, and that term is at least one column to the right of the leading one term above it. And row 4 does not have any leading one terms, so we don't need to check for that rule. So currently, this matrix is in row echelon form because it satisfies the first 3 rules. Now, if it also satisfies the fourth rule, then we can say that this matrix is in reduced row echelon form. So let's check that. A column containing a leading one also has all zeros above and below the leading one term. So this rule only applies to columns containing a leading one. So if we look at this matrix, columns 1, 2, and 3 have leading one terms. Column 4 does not have a leading one term. So we only need to check the first 3 columns. Well, the first column here has a leading one in row 1, in the row 1 space. And so all elements below that leading one have to be 0, which they are. So column 1 is good. How about column 2? The leading one element here is in the second row of this column, and the term above it has a 0, and all the terms below that leading one are also 0, so column 2 is good. How about column 3? Well, the leading one term here is in row 3, and it also has all zeros above and below it, so column 3 is good. So since this matrix satisfies all 4 rules, we say that this matrix is in reduced row echelon form. Let's go ahead and check out another example. All right, let's say we have this matrix. This is a 4x5 matrix, 4 rows, 5 columns, and we want to find out if this is in row echelon form, reduced row echelon form, or neither. So we don't have any rows consisting entirely of zeros, and if they were in existence, they would be at the bottom of the matrix, so rule number 1 is good. Rule number 2 states that all the other rows, which are all 4 rows in this matrix, that are not entirely zeros, have a first non-zero entry as 1. So the first non-zero element that we encounter going from left to right on each row should be a positive 1. Well, we can see that that is true for the first row. How about for the second row? We have a 0, and the first non-zero element that we encounter is a positive 1. So that row is good. How about for the third row? Well, we have a 0, a 0, a 0, and a 1. So the first non-zero element that we encounter is a positive 1. And finally, for the last row, we have 0, 0, 0, 0, and 1. So that row is good. The rule number 2 is satisfied. Rule number 3 says that leading ones of each row are at least one space to the right of the leading one above it. So if we look at row 2, the leading one term is in this column, and the leading one term in the first row is in this column. So this leading one term here is actually 2 spaces to the right of the leading one term above it, which is here. So that's good. How about for the third row? Well, this leading one is in column number 4, and it is at least 1 column to the right of the leading one term above it. And finally, in this column, for this last row, the leading one term here is at least 1 space to the right of the leading one term above it. So that's good. Well, it satisfies all 3 rules, so we can temporarily say that this matrix is in row echelon form. Now, if it also satisfies rule number 4, then this matrix is in reduced row echelon form. So rule number 4 says that every column that has a leading 1 has to have zeros above and below the leading 1 element. So this rule only applies to columns that have a leading 1 term. So column number 1 does in fact have a leading 1 term, and all the elements above and below it are 0. So column 1 is good. Column 2 does not have a leading 1 term, so we don't need to check column 2. Column 3 has a leading 1 term here, and the elements below it are 0, but the element above that leading 1 term is a negative 4. And therefore, this matrix does not satisfy rule number 4, but since it satisfies rule number 3, we can say that this matrix is in row echelon form. Sorry, that it satisfies all first 3 rules. And let's do our last example for this video. This matrix right here is a 3x4 matrix. It has 3 rows and 4 columns. And let's check if this matrix is in either row echelon form, reduced row echelon form, or neither. So the first rule that it has to satisfy is that all 0 coefficient rows are at the bottom of the matrix. Well, this matrix doesn't have any rows that consist entirely of zeros, so rule number 1 is fine. Rule number 2 says that all the other rows that are not all zeros have a first non-zero entry as 1. So each row has to have a leading 1 term. So if you look at row 1, the first non-zero entry we encounter is a positive 1. So row 1 is good. Row 2, the first entry is 0 and the second entry is 2. So the first non-zero entry that we encounter, which is this 2, is not a positive 1. So row 2 is not good, and therefore we can't say that this matrix will satisfy all 3 or 4 rules. So this matrix is not in row echelon form.